Hi, my name is Anthony Saranino, and I'm a grade 10 student at Bishop Bryan Catholic Secondary School. I've been doing Basic Science Fair since grade 7, and I am truly excited for this year's project. Throughout all my projects, this one is something I am most excited about. The purpose of my project was to design and create a non-medical face mask that is not only comfortable, but has the ability to amplify your voice and has its own voice-to-text converter system that can be used to present information in classrooms or meetings. The mask is also very sleek and has its own self-sanitizing system. I chose to do this project because of my mom. Since she was forced to go to school in this pandemic, she's always been talking about the struggles of communicating with her students and wearing a non-comfortable mask. Luckily for me, she brought this upon me just as I was thinking of a science project. I did some research on the topic and I was really excited. My brain's need for answers got me to where I am today, and this is why I chose this project. COVID-19 is an infectious disease caused by the newly discovered coronavirus. There are 7 types of coronaviruses. The new one, SARS-CoV-2, Severe Acute Respiratory Syndrome Coronavirus 2, most known as COVID-19, was discovered in late 2019 and is still drastically affecting the world today in 2021. Most people infected with the COVID-19 will experience mild to moderate respiratory illness and recover without requiring special treatment. Masks are a simple barrier to help prevent your respiratory droplets from reaching others. Studies show that masks reduce the spray of droplets when worn over the mouth and nose. You should wear a mask even if you do not feel sick. The mask protects the respiratory system and can save lives. Studies show that if masks are worn properly, they can contain 99% of the virus. At the rate these masks works, if everyone were to wear one, we could contain this virus much quicker. Knowing this, being able to create a mask that is appealing to others and has a lot of advantages will only help to enforce mask rules. There are many masks on the market. The main masks include cloth masks, medical masks, one-layered masks, 2-layered masks, certified medical masks, and face shields. Although these masks help stop the spread of coronavirus, there are many issues with them. The first issue is how comfortable the masks are. Masks can cause rashes and can also cause irritation around the ears. The second issue is the breathing quality. Masks help prevent the virus from coming in and spreading, but they also prevent the air from coming out. Masks are hard to breathe in and make the area around your mouth extremely hot. The final issue is the most important. When people are wearing masks, it is extremely hard to communicate. Masks make your voice sound muffled and distorted, but they also take away the visual cue when you are talking to someone. Before beginning to complete my project, I set out some engineering goals for myself. The first engineering goal was to create a mask that is comfortable to wear. Number 2, create a mask that protects the user and the people around them from the virus. Number 3, create a mask that improves the quality of the communication from the mask. Number 4, create a mask that does not require bulky components attached to the person wearing it. Number 5, create a mask that will be effective to talk to people in big groups. Number 6, create a mask that looks aesthetically pleasing and involves sleek components. Number 7, create a container for sanitizing the mask. In total, I created 6 prototypes. Each prototype was 3D designed and 3D printed using a variety of filaments. After completing each prototype, I added the electronics and then ran each prototype through a series of tests. I used 6 testing methods to gather information on each prototype. One test was a smoke test, the other test was a sound test, and the other 4 were survey-based tests. All of the tests provided me with enough data to make my current prototype. Users wear masks in normal fashion. All audio is sent to the Raspberry Pi Windows PC. The Raspberry Pi has software ready to run. The Raspberry Pi is able to amplify your voice and output it through speakers. It is also able to use the voice-to-text converter system to present information on a monitor. My current prototype was 3D designed using Fusion 360. The design was a result of all the survey information collected, which was very similar to the shape of the N95 mask. The one main difference is a large hole over the mouth so that you could read the person speaking's lips. The mask was 3D printed on a CR Ender 5 using TPU filament. It took a total of approximately 6 hours to print the mask. Once the mask was completed, I conducted the first 2 tests. The first test was a smoke test, and the second test was the sound test. I conducted both these tests multiple times. This is an example of one of the smoke tests. The smoke represents someone sneezing or coughing. My next step was to get 10 people to wear the mask and complete a survey. I then collected all of the surveys and processed all the data. During testing of the final prototype, I was able to determine the following. 1, the mask was above average in comfort. 2, the mask was above average in breathability. 3, the mask was allowed people to understand the speaker. 4, the mask was able to stop the spread of COVID-19. And 5, the voice-to-text converter system was very useful in presenting information. The software functioned according to the way I wanted it, although there are some changes I would like to make. Hello, my name is Anthony, and this is the voice-to-text converter. In conclusion, I believe through all my tests, I was successful in completing all my engineering goals. Although completing the project was a success, I still believe there was some room for improvements. The first thing I would like to improve involves the software. Not only would I like to add a preference setting that would allow the user to change the volume output, the font, and the size, but I'd also like to make the speed of the translation quicker so it was easier to understand. I would do so through the Google APIs. I would like to make the infill on my 3D prints to 5% to make them more flexible and potentially more comfortable. Another thing I would like to do that involves the design is adding a gel-like substance around the mask that will possibly also help with the comfortability and will prevent the user from getting rashes. The final thing I would like to add is a mini camera that projects itself onto the mouth and captures it and then projects that image to a screen. That would make it easier for the people who are looking at the screen and paying attention to the lesson understand much easier. Other than these improvements, I'd like to improve on my tests. Due to the restrictions during this pandemic, I was only allowed to survey 10 people. If the restrictions were to drop, I would like to survey closer to around 50 people. And finally, I'd like to get in touch with schools around my areas and potentially give them this mask for them to use it as a pilot project. It would be cool to see how people who would actually be able to use this mask would react during the day. I would want to see how well my mask works in an actual real classroom.